if S can be segmented into space separated sequences of one or more dictionary words. What we mean by that is that if I have this S, I should be able to segment this into some words which should be there in my dictionary. So you can see leet is there, so I will just put one word as leet. Next word I can put as code, and for sure I can have a repeated word also. For example, as you can see, I have an apple, I have an apple, I have a pen, I have a pen, I have an apple, I have an apple. So for sure the answer is true for this. Let's take the next one, which is cats, dog, cat. So in this, I have cats, okay, I have cats, okay, I have a dog, okay, I have a dog, but there is no an, there is no an, okay, that is not possible. Let's say I have a sand, okay, I have a sand, I have a and, okay, I have a and, that's also possible. I have a cat, okay, I have a cat, but still, what about this OG? That's not there. So okay, ultimately we tried on all the possibilities and then we figured out, okay, it is not possible. So for sure, let's take a normal example. Let's take this example, cats and dog. Cats and dog. You can see cats and a dog. We have for sure. If we just go and ask, we also have, if I just say that I have cat, I have a cat. If I say I have a cat, I have a sand, I have a sand, but there is dog. Oh, there's a dog also. So for sure, I have it. There are ways, at least I just want one way to get this specific thing out. So for sure, what you saw above, you had the option of cat. So basically you can just say, okay, I have the string S. I just want to figure out if it is even possible to make this string out of this word dict. So which means every of these words should be possible. So if I am standing here, I should be able to get one word. Okay, standing here, I can get a cats or I can get a cat. Anyway, so I just said, okay, standing here at the first place, I'm just looking if I can get something. Yeah, I can get a cats and I can also get a cat from my word dict. Okay, if I can get a cats, then my search space will actually go on and try for the remaining part of the string, which is and dog. If I can get a cats, my search space will go and ask for and dog. Is it possible to actually get that? And if I get, and if I say, okay, I just take it my cat only, then my search space will say, okay, my cat is already in my word dictionary. Now go and try for your sand dog. Now again, for this and dog, I'll go and try, okay, do I have, like, for this entire thing, I'll try. I have to try for everything. Do I have a? Do I have a an? Do I have a and? Do I have a ANDD? Do I have a ANDDO? Do I have a ANDDOG? So like I will have to kind of try for everything. Now you will see that, okay, it is not much useful to try for all this stuff. Rather we can just simply say I will just simply try for just the strings which are already in my word dictionary, which means at this location I will try for and I just go and look for, okay, I'll go and look for my word dictionary. So at this location, I will go and try to make, is it possible to make a cats, dog, sand and cat? I'll try to make all these. I try to make, okay, is it possible? So I'll just ask him. So you'll see, okay, yeah, it is possible. And can be possible. Now my search space then reduced to find if it is possible to make a dog. Then if I can, I'll try to make same way. I'll try all the possibilities for this first, like for this string. And I figure out, okay, yeah, it is possible to make a sand. Okay, sand is possible. Then my search space will reduce to dog. So you will see that what if I ask you after dog also I would have some other characters. Let's say XYZ. So after dog also, let's say I would have some XYZ. So it is just that you found out, okay, there was a way to make a cat and there was a way to make a cat sand. Right? So ultimately you just are asking me, is it possible to make dogs XYZ and same dogs XYZ. So you saw, okay, in this entire recursion tree which you are making, there are repeating subproblems, which means you will ultimately go and try to find the same thing here also and here also, which is a repeating subproblem. So for sure, I know one thing, okay, I will try on for all the possibilities. I know, okay, I will encounter some repeating sub problems, and to encounter that I'll simply use my DP, which is memoization. And how DP? Okay, I just want to know, add this index, because I am saying, okay, add this index. Afterwards, is it possible to make that specific string, remaining string from I up till the end, is it possible to make that specific string up till the end using the word dictionary? Okay, now let's come on to actually how we will implement it. As simple as that. So we saw that, okay, if I am at that specific index, I will just try on. One way is I'll try on for all the possible strings. This string, 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 and check if that string is actually in my what dictionary or not. Or rather, there is a better way that I'll just, okay, I will check for, okay, starting from the index I, do I have a cats? Then starting from index I, do I have a dog? Oh, it is like when I say starting from index I, I'll just compare, okay, index I, I'll just keep index J here and then keep on comparing, kind of 2 pointers, and just check if it is actually matching. At any point, if it doesn't match, try for the next word. Okay, yeah, D and C are never matching. Okay, try for this word. S and C are not matching. Okay, try for the next word. A and C are not matching. Okay, try for the next word. C and A are matching. Okay. A and A are matching. Okay. T and T are matching. Okay. Yeah, for sure this word is matching. For sure this is possible. Then my next problem will become try from this character, which is whatsoever I plus length. We will see what it is, but yeah, it will try for the next space, obviously the next possible string, which I have to verify if it is possible to make that or not. So this is how a simple comparison will look like. But let's see how we can actually build our entire output. So if we just go and look back, our main task here is that if I am starting off with some character, I just need to know if I'm just starting off with this character, let's say I. As I showed you, I just need to know if this specific string of length, let's say length is 4 right now, but for you to show, I just want to know if that specific string is actually in my word or not. So I'll just say, okay, I plus this length minus 1 will be the last index of this. So I will, okay, if I can verify if I up till for this length of 4, if it is actually in my words, then I can try on for I plus length. Next index to try on for will be I plus length itself. So one thing we have got to know, okay, if I am at index I will try on the specific length. What again, the length I'll choose in from the word itself, which means my word dictionary. My word dictionary will tell me, okay, you can try for the cats, you can try for the dog. So I know cat's length is 4. So starting at this index, I will try for a length of 4 and I will check, okay, this string from the S of length of 4 starting from index I, is it matching with the word dict that specific string? If it is yes, okay, I can try on next from I plus length. This is the next I'll try, and that's a simple recursion which it will handle. So you will see that in a simple recursive call, I'll just simply ask a solve, and as you saw, I'll starting from the index 0. So my base case will actually become, okay, if my index reaches super end, which means if my I reaches super end, which means more than equal to n, then I can simply return a true. You can also put a equal to n, that's also okay, because it is increasing just one by one. No, it is not. It can actually increase with the length itself, which can go greater than equal to n. But you make sure you have to handle the condition that it is not going beyond n. We'll see. What I mean by that is, if you have a string, let's say all these characters, now you will have to check that you are not going beyond this, as in to have a complete check. You have to make sure that the word which you are checking from the word dictionary should actually be matching this specific last end word. So we can handle both the cases in our actual function, which we actually do, which means this function we actually handle that. Let's see how. But ultimately, if I reach the end, I'll simply return a true, because yeah, it is possible to make the entire string S. And we will handle this case that, okay, if we are some index I and we should not actually go beyond, as in like we should end at last character. That's it. We should not go beyond that. That we will handle in our recursive call. And for sure, as we told that it is a memoization, so we will have to put that for every index, if it is actually we have encountered that, because you saw in this case for this index I, you had actually encountered this. So basically you can store that specific value. Okay, I have encountered that, and the number of, and is it possible to make after this index? Yeah, true or false. That's it. I only need true or false. That's it. Now comes the interesting part. Now you saw that I will go and try for all the words in the word dictionary. Again, for that specific index I, as I showed you, for that specific index I will go and try for all the words in my word dictionary, and I will just have to check if that specific word matches with this word. Now let's imagine that you would have been at this specific index I, so you would have gone and checked is cats matching with dog? But then you will see, okay, cat's length is 4, and you will see I 1 2 3 4. Okay, I plus 4. Oh, that's actually equal to n. So I just, as I showed you that, okay, this is the last index. This is the last index. So if I am at this index I will check, okay, for the length of 4, last index will be I plus length minus 1. So this last index value should be in the range of n itself, which means it is the last index. So if you are about to compare something, it should be actually in the string s itself, right? So I'll just do one thing, okay, if I plus length minus 1, which is the last index, which is, okay, if I am standing at the index I and I'm expecting the word length to be this length, so I know the last index for that specific character of word, like for the specific string of word length, will actually be I plus length minus 1. That will be the last character. That will be the last index for the last character. And that index should actually not go beyond n. So if I just, now here also, you can handle either in this condition or you can handle here itself. That if it is equal to n, then return a true. If it is more than n, then you return a false. So here itself I handle that, okay, I should be actually in the bounds of my entire string. I should not go beyond. I should not go and check, okay, like it can actually happen that, okay, you are at let's say last first string, you have some characters in the beginning and the last is and then your word, let's say had, like word dictionary had different characters, for example, and this. Then you cannot go and compare and with and this. That's not possible, because last character is itself, because and is saying, okay, length is 4. Length is 4 as in, okay, length should be 4. So I should be expecting a character here, which is not even there itself. So it is the reason I compare only when I plus length minus 1, which is the last character index is actually less than n. If it is more than or equal to n, then simply continue. Now, when I am sure, okay, this is actually in the bounds, then I'll simply say, okay, is this character? I'll just check, okay, if that character, which is this character, oh, is actually matching. So if this character, which means if this entire string from I to the length, if it's actually in my word dictionary, because I'm iterating the word dictionary itself, if that is matching with the specific substring itself from I to length of 4, if it is actually matching with the word, great bro, great, super great. Just try for I plus length. As you can see, next index to try for will be I plus length. I plus length itself is the next character which I will actually try. This is the next character from which I have to go and try, and that's a simple case. If the word is matching and also I plus that length after this is entirely matching, which means for this index I, it's also matching. So I just bifurcated it into two parts. I just said, okay, if this part is the word out of word dictionary, it is a word. If this is matching, and this remaining part I asked the recursion to bring, if it's also true, if it's also inside my word dictionary, then okay, for I it's also true. So I'll simply say for dp of I it's actually 1, which means simply return true from here itself. Else, if it is not possible, then simply return dp of I as 0 and return false. See the code, it's pretty simple, exactly what we saw above. It's just that firstly, let's see the recursive function. So in this, we have a base case that if I is more than or equal to s dot length, simply return true. Now we have a simple memorization case. The actual case is when I have to go and try for all the words in the word dictionary. For that specific word, I will check what is the current size of that word. I will go and check. I'm about to compare with the string s, right? That specific word in the string s after the index, like on the index I. So I'll check, okay, I plus current size minus 1, which is the last index. If I take this current size from the word in the string s, if that is more than or equal to my string dot length, bro, I should continue, because it is not only possible to compare this word. Else, if it is possible, then I will get that specific substring starting from index I with the length of current size. And if it is equal to my specific word which is given in the input, bro, very good. Just try for the next index. Next index is I plus current size. If this is true, then only I will try, right? And if this is also true, which is a recursive call, which will return true or false, If this also returns a true, then I can simply mark my current DP of I, because this was, if I just bifurcate that again, it is I plus current size. This you ask from recursion, if it is true, this current I to this length, which is the current size, if this is also inside my word, then for sure I can also, starting from I also, you can actually form the string can actually be formed from the word dictionary words. So I can simply return a true and mark my DP of I as 1. Here I mark my DP of I as 0 if it is not possible, and simply return a false. So you will see that I initialized my DP with -1. If it is possible, it is actually a 1. If it is not possible, it's actually a 0. And that's how I can populate my DP values. So DP is not a Boolean value here. DP is actually an integer. And why it is needed? Because I have to put in 3 values, -1, 1 and 0. Thus I need my DP to be integer. Many people just do a mistake, they put DP as Boolean, but this is not possible to put it as Boolean. And for sure, we will have some global variables just to assign that DP, word dictionary and S, so as to use it in future. I assign those and initialize my DP with the word length and with the -1 value, and then simply ask to start from the index 0 and check if it is possible to make the entire string from the words. And with this, you saw that the time complexity will actually be, you are going on to all of your indexes of the string S. Let's say the string S is of length n, right? The word dictionary, the number of words in the word dictionary, let's say they are m, and for each length of the word dictionary, it's actually k, which means the length of each word is actually k. So with this, I can know, okay, I'm going on to all the characters of my string S, which is actually O of n. And for every of those characters, I'm actually trying on for all the words. Number of words I have is m, and length of each word is a k. So ultimately, this entire loop will and can in worst case go to O of m into k. So in worst case, my time complexity is O of n, which is for the index I, and m into k for the word comparison. That is the time complexity for us. And space is for sure, we are just using a DP, that's extra space which we are using. Now, this is the top-down approach, which is for sure. And the same way, if you still want the bottom up, although the bottom up will also be exactly same. It's just that we are seeing bottom up because maybe it can be used for optimization, but after writing that, you will see that, okay, there is no optimization possible for bottom up. But yeah, for your simplicity, let's see the bottom up, it's exactly same, nothing much. That is just that, okay, if I am at the index j, right? Now, in top down, you are at index I or index j, you compare forward, right? In bottom up, you need to have the backward information because you are going forward. So if I'm at the index j, I should be knowing, okay, this length of 4, which means, and this length of 4 again, I'll grab it from my word dictionary. Let's say my word dictionary have some specific words, 1, 2, and again, like this is one word, this is one word, and so on and so forth. This is another word. So I'll just go and check this specific word length. I'll go and compare this length with this specific string S length. So I'll just check, okay, starting, if I am at the index j, and okay, I need to compare the length 4, which means I am at index j, I need to compare the length 4. If I go back, so this index after four characters back, this specific index which I am thinking of comparing, its index value will be nothing but j minus 4 plus 1. That will be this will be j minus 4 plus 1, last index value. So one thing is that, okay, I can compare, firstly, I need to compare, if I am starting at this index, I need to compare if j minus length plus 1 after this index of a length of this, let's say this is the length, because this is a length is 4, so at this index for a length, is this string matching with the word itself or not? That is what I am about to compare. But as you were saying previously also, that, okay, comparing is one case, comparing the string with the word is one case, but also the remaining part should be solvable, should be returning a true. So I will say that, okay, this part I will compare, this string should be actually in my word dictionary, but this, which is ending at here, which means DP of j minus 4 should actually be a true. So when I am building, I'm again building from left to right. I'm building again from left to right. If I'm standing at this location, I will firstly check, okay, the length I need to compare is 4. So I need to know and compare this specific length of 4. I'll compare that with my word dictionary word. Okay, that's great. But I also need to make sure that, okay, dp of j minus 4, which is this specific index, this should also be a true. If this is not true, then okay, it's not even possible. Which means, let's say if you would have been starting at this index, if this entire string is matching, but this part is not true, so which means you cannot even make cats. So it's not even possible to make the further part. So make sure, okay, it is possible to make the up till this index. It is possible to make. Only then you can actually start comparing. So it is as simple as that. It's just that one condition. If you are, let's say, at index, let's say I, right, and if you know that, okay, you have to compare the length 3, so you will go and check, okay, this index specifically will be I minus length plus 1, and length is 3. So I know the substring formed will be substring form starting from the index I minus length plus 1 of the length. This is a substring which I will compare with my word dictionary word, but then it will go and point to I minus length. This I minus length is actually minus 1. So if you just go and ask dp of I minus length again and again, so this dp of I minus length can actually become negative. So this value can become a negative dp of minus 1, which means you are trying to access negative index. This will give you a runtime error. So make sure, okay, just have a quick condition that, okay, if your I minus length, if it is actually I minus length, if it is actually a minus 1, I minus word length, if it's actually minus 1, then also, okay, it's also true. It's also true. So we figure out one thing. I'll compare the word with my this specific string length, and I will go and check for dp of this j minus length. I'll check if that is true or not. If that is true or not, which means I minus length or j minus length, anything you can write. J minus length, I'll check if that is true or not. If that is true, okay, great. But this j minus length can also be minus 1. So if it is minus 1 or this is positive, in both ways I can say that great, I am good to compare the next characters, like next strings. So the same thing, if this thing is negative, or the I minus word length, if it's actually a true, because if this is negative, then this will never go here. So it's a reason. If this is negative or this is true, then I am great to say that, okay, now I can go on and try for the next. So ultimately we saw one thing, okay, I'll compare the subs, like I compare if I am standing at the, let's say, index j, I need to go and check for j minus length plus j minus, this is j minus length plus 1 index with the length of length. I'll compare this specific string, which means s dot sub str starting from index j minus length plus 1 of length. This should be matching with my word. So I'll compare this entire thing that, okay, I minus word length plus 1 and word length, that should actually be like, it's a string which I am trying to form, and that should actually match with my word itself. Let's see the code. Again, the above how we saw top down, it's exactly same, that we will try on for all the indexes, right? For every index you saw that I need to compare that with the word, but here it's just that I'm going backwards, which means if I am at the index I will just try for this specific word to match with my word dict word, and then I will go and check if it is possible, if it is possible to say dp of I minus length, if it's actually true or not. So I'm just checking backwards. I am at the index I'm checking backwards. Earlier I was checking forward. That is a top down. This is a bottom up, which means bottom up means your base answer should have been calculated. So here I'll just check, okay, firstly I have to just have a quick check if that I minus word length, if it is less than minus 1, okay, we figured out, okay, that can be minus 1, but if it is less than minus 1, which means I'm checking a very big string. So simply continue. This is the same case, exactly same case what we saw while we were doing this entire thing, that if it is big string, don't compare, simply move on forward. Now if it's actually a okay string, then I will first have a quick condition. If that thing I minus length, if that is minus 1, then okay, that's also okay. And or if dp of I minus length, if it is 1, which means, okay, if it is 1, then I'm for sure saying I will be able to form this portion. For sure I will be able to form this portion. And if it is actually -1, which means it is empty right now, so that's always okay. So if any of this is true, which means firstly it will check this condition. If it is true, then it will not even go there here itself. So if it is actually true, I can simply say that I can now try for this specific substring, and it should match with my word dictionary word. So I'll just get this substring out, which is nothing but starting from index I minus length plus 1, and the length is nothing but length. In C++, you need to pass in the first character of the like, let's say if I want to find the substring starting from this index. So let's say if I am at this index I, but I want to know this substring, so I will have to pass the first character of this and the length I have to pass. This is what I have to pass in C++, but in different language it can actually go different. So here I will have to figure out the first character, which will be I minus length plus 1, and the length will be length itself. So I minus length plus 1, with this length it should match with my word. If it is matching, wallah, blow wallah, I can also say that my DP of I can actually form, which means my DP of I is actually a true, because I know that DP of I minus length is a true. This specific word is also in my word dictionary, so for sure my DP of I is also true. So my DP of I is true. I can simply break. Ultimately, I'll try on for all the indexes, and I just have to make sure ultimately in the super end, if this is my entire string S, ultimately the super end, it should be possible to form. So I'll simply say that DP of S, like length minus 1, which is the entire length, S dot length minus 1, this is the last index, it should actually be also true, which is the same condition that you were checking, that starting from the index 0, it should be a true. If I go back, and here it is that you are checking that deep solve of 0 is actually a true or not. Same way, I'm just checking that my DP of last character is actually true or not, because I'm building in from bottom to up. That's it. It is named as bottom approach. Again, time complexity is still, this will go to m into k times m words, each of length k, and this will for sure go of n length. So time is still O of n into m into k, with a space of O of n because of TP itself. Can we improvise it? The answer is yes, depending upon we are working on strings and we are comparing strings. As soon as string comparison comes in, you can think of multiple string algorithms. But on a high level, to compare strings, there is a standard approach known as trie, in which trie is just used for pre-computing some portion that you don't have to do it again and again. What we mean by that is, why was this n into m into k? For every character, I am trying on for all the words, and every word has a length of k. For every character, I'm trying for all the m words, and every m word has a length of k. If I bifurcate that, it will simply look like, okay, my m of k is actually 2 into 1 e 4, while my string length is itself 300. So I'm just ultimately saying, okay, my length is 300. I'm at this index, right? And I know, okay, my length is 300, but I'm doing a comparison which is worth of 2 into 1 e 4. This is the comparison which I'm doing. I'm saying, just a second. If you're matching a specific word, how you are so dumb that you are doing a comparison of 2 into 1 e 4? Why can't you say, okay, if you're matching a specific character right here, if that can be maximum of length 300, so why not the maximum comparison which can be done will be of length 300? That's it. Why you are doing comparison worth of 2 into 1 e 4? That's so obvious that it is so super dumb. So what I'll do is, okay, I now know one thing. I'm doing way too much comparisons which I should avoid. For that, I know, okay, my length is itself 300, so I should do my comparison worth of this specific length only. So at the index I will max to max do the comparison of length n. That's it. And then I'll simply end here itself. But for that, why you remembered why we needed to do a 2 into 1 e 4 like comparison? Because it's a word dictionary, and every word in that. So it's a word dictionary. And in that every word is there. Oh, if I go back and see, so I know, okay, I have my word dictionary, and for that every word is there, and I was comparing that every word. I have 1000 words. But I know still that, okay, the maximum match I could have is 300. So what I can do is, okay, I can do the matching later on, but firstly I have to pre-compute something that, okay, how the match would look like. Now to pre-compute that, okay, you have to match some characters. You have to pre-compute something, okay, the match should be as soon as possible. Okay, if I am not possible to break, I should be possible to break out as soon as possible, and I should be able to compare every word in the word dictionary simultaneously. What I mean by that is, okay, in my word dictionary, as you remembered, we had cats, we had dog, we had cat, we had sand, and we had and so on and so forth. So I am saying I need to minimize my comparisons. Earlier I was going on the cats entirely, then I'll go on my cat. So it is like, okay, you are going on the cats, you are going on the cat. Cat is a part of cats. So if you have gone on to cat, then why are you going to cats again from the very beginning? That is a wastage of comparison. So with that reason, I know, okay, I have to build some pre-computation that, okay, I should only be, okay, for both of them combined, I should only be going on to, here it is 3, here it is plus 1, 4. So in total comparison, like in total, I should go on to 4, and that's it. So for that, I will just, from this word dictionary, I know that in the word dictionary I have m words and each word is of length k. I will do some pre-computation and build a trie out of it. We will see that how the trie, again, you have not watched a trie or you don't know trie, just write on YouTube trie by Aryan Mittal. You will get a video. That's a very short, concise video of trie of like nearly 15-20 minutes, and with that you will see the implementation of trie, how to implement that, how to actually use this, where all we can use tries. Cool. But in this case, I know, okay, with this input of word dictionary, I have to build a trie so as to make it much more easier for us to start comparing. Now a trie simply says, okay, we will have a root. Root is nothing but, okay, now after root, okay, I will try to build this trie, CATS, okay, CATNS. Now as soon as you end at that character, you just mark, okay, if that word is possible to make. So is word true. Rest of them will have is word as false. Okay, great. Then you get a dog, DOG. Okay, DOG. Oh, for sure it is also true. Then SAND. Okay, SAND. Okay, that is also true. AND. Okay, AND. So you saw, I am making another branch for it for every new character which I am encountering. That's also true. Now come the cat. You saw, C. Oh, that is following the cats, which I have already made the cats, that is following that path only. C already made, A already made, T. Oh, T is made, okay, but yeah, that is a new word which can be formed. So it is word is true. So you saw that if any way whatsoever, if I want to search for, okay, is cat possible, is cats possible, so I just have to go in the depth of this tree. That's it. And I know one thing for sure, my string S, let's say if I am comparing S, A, N, D, A, B, C, D, E, F. So, okay, I'll compare if S is there. Yeah, S is there. So go on to S. Then A is there. Okay, go on to A. Then N, yeah, N, D, and then D. So it is that, okay, I know one thing. Okay, I want to compare that specific character. If it is there, then go on to its child. If it is there, go on to its child. And I know, okay, I'll compare only the string S. So I will be in the worst case going on to this entire depth of length N, which is of string S. And that's the reason. If for any character, let's say I want to compare, I'll compare just the entire depth. And that depth will at max be O of N. Because I will just simply do a comparison of this length N itself. Now, let's have a quick check that how we will do this. Again, everything remains as simple as that. But it's just that a few conditions will change. That if you are at specific index I, right, now you will start comparing. Let's say you will have to compare if cat is possible or not. Again, you can also go reverse way, which means if you are at I, you can also compare the previous part also. But yeah, for simplicity, just to showcase, okay, how the things will build up, I'm going from the very beginning. So if I'm at the index I will go and check. I'll go and check, okay, cat. Again, I will go and traverse. Okay, I'm at the index I have to go and traverse my what? My trie to check if actually it's possible or not. So I am at the index I encountered a C. Yeah, that is there. Go on to that. A. Yeah, that is there. Go on to that. T. Yeah, that is there. Go on to that. But yeah, it's a word also. If it's a word, then DP of that specific, because I will start off with my J. I will remain here. I will go off with my J. my j will be here and then here, and as soon as my j is going, my trie, I'm also going in, like inside my trie also. At this, it's saying okay, it is a word, it's actually a true, which means I will be able to possible, like I will be able to make this as a word. So for sure make this dp of j as a true, and then keep on going. Okay, s, yeah, it is also a word. Okay, make that also a true. Okay, then a, oh, there is no a, for sure. Okay, simply break here. There is no a, simply break here. Now you saw that, okay, because of this specific I was able to just, again with this specific with this o of n time only, I was able to build that, okay, dp of this specific j is true and dp of this specific j is also true. Now I'll go on and do my next character, which is a. I'll check, okay, is a possible? Yeah, a is possible. Yeah, okay, j is here, a is possible. Try for next. Is t possible? T is not possible. Okay, so I'll simply say it's not possible. And again, even if it is possible to go on to that location, I will mark true only when I encounter that, okay, a word is completed. So I got to know, okay, it is not even possible. So for sure there is the by default dp value is false. So for sure I'll go on to next character, I. Then t. Okay, t is possible? Nah, not possible. Okay, but it was already true, so no worries, go on next. S, is it possible? Yeah, it is possible. A, it is possible? Yeah, it is possible. N, it is possible. So j is here, then j is here, then j is here, n, and then j is here, d. So you saw, okay, yeah, it is possible. So I'll just simply, yeah, the word is true. I'll simply mark that the word is true. But make sure, remember one thing, when I started off from here itself, so I should be making sure that this portion is a true. This portion is a true. Only then, because see, if I am at this index I and I am saying this is a true, so I am saying the entire portion backwards is actually possible to make. So for this, and you are only comparing this entire portion right now, so you should be making sure that you will start comparing only when your dp of, let's say if you are at I. So if you want to start comparing, you should say, okay, dp of I minus 1 should be for sure true. Only then you can start comparing from I itself. So here, if you remembered that at this index, right, you started comparing, which is not even possible, because this is not even possible to make. Then how were you started comparing at A? Not even possible to compare starting from the index A. Let's say you were comparing from here. No, you can't even compare. You can't even start comparing. Even if my T, S, A, N match, still I cannot mark my N as a true because this was not even matching. Okay, if I go on to this I, now I'll say, yeah, this dp of j is a true, which means the previous portion is actually possible to make. Then I can start comparing from I itself. Okay, great. So we were actually here. I can start comparing because I know that dp of j is a true. So I can start comparing from here itself. So I can say, okay, my j is here. Is my a here? Yeah, my a is here. Then I'll move my j. Is my n here? Yeah, my n is here. Then I move my j. Is my d here? Yeah, my d is here. Oh yeah, it's also a word. Okay, mark that as a true. Okay, go on. Is my d here? No d here after that. Okay, cool, no worries. Simply move on. Move on here. Now you will see, move on here. My dp of a is not true, which means I am saying for sure it's not possible to make this old part. So simply you can't start comparing. Go on next. Again, it's not possible. Go on next. And how to know it's possible or not? By simply comparing dp of I minus 1. Now with dp of I minus 1, yeah, it is possible. Okay, it's possible. Great, bro. Simply try on with your j. Okay, d is here. I can see d is here. Then my j is here. O is here. Yeah, O is here. Then my j is here. Sorry. Then my j is here. Then my j is here. Yeah, my g is here. And then ultimately I reach the super end. Oh, for sure. Again, when I was reaching here, it is a word which is true. Simply mark it as true. Now you will simply see that your final end s of dp of length, dp of s dot length minus 1, it's actually a true. Now this to simply say that, okay, you are actually able to possibly make the entire string up till this specific index, which is end, and that's for sure you will be able to make the string s. That is how you can actually start comparing. So it's just everything will remain same. It's just that how we will compare will actually differ. And again, it will be much more easier if you will compare starting from the index I going forward, because you saw, okay, I have to go on and j, I have to go on comparing that. If you compare backwards, if you, let's say if you are at the index I, and if you want to see if this character is there or not, then you will have to, if I am at this index, I will have to go back, which means I minus length plus 1, and then I'll have to go and compare the same stuff. So it is much easier to actually start comparing from index I itself. Right, now let's see the code. It's pretty simple. It's just that you need to have a trie knowledge how that trie is made. So for that, I highly recommend go and watch that trie video. I will put that in the link below also, that how to actually learn and understand trie. Now a trie simple structure is, okay, you have a is word, as we saw that a trie, because it is basically a trie is a node, right? A trie is a node which is storing the pointer to the next children to him, and also just storing, okay, if that is a word or not, and the character, if he wants to show the character or not. So you will see that, okay, in my trie node, I'm just showing if that is a word or not. This is the unordered map from the character, which is the current character, to the trie node, which means to the next children, and that's an unordered map. So from the character C, I can have character D, E, C, F, and so on and so forth, and these all are nothing but my trie nodes. So that is nothing but my children. Unordered map. Usually people keep vectors, I keep unordered map because of simplicity. Now the simple trie building will actually work like, okay, we will have a root node. Now from that root node, I will firstly have to build my entire trie. To build the trie, I will go on to m into k, which means go on to all the words of length k, which is go on to all the words in the word dictionary. So firstly, you will get the current, you will firstly have the root node, and then you will simply start iterating on the word itself, current word, on all the characters, and will start building the trie. Let's say A, let's say firstly you encountered the word, let's say the word was cats. So you encountered the word C, which is C, cat. So you saw, okay, in the child of my root there is no C. So if there is no C, so make a node C. Okay, I will say I will make a node C. Okay, that specific character I'll make my current child C. I have made. That's a new node I have made, and then simply I will go on to that specific child, which is C. Then I'll go on to my next character is A. Again, C's A child is not even there. Okay, make a A child. Then I'll go on to next character, which is T. Okay, if it is not there, even there, make a T. Then I go on to next character, which is S. Okay, it's not there, make a S. So you will see I'm going on to all the characters again and again, again and again. Again, if you don't understand this trie structure, just go and watch the trie video. Now, as soon as I have reached the super end, which means my entire word is done, I have to mark, because I am currently at this specific trie node. So I have to mark, okay, this is the current trie node which I am at, and its word, okay, its word, I'll mark it as a true, because this is a word. And same way I'll go and build this entire trie structure for all the nodes of like all the words which I have in word dictionary. Now when this entire thing is built, now I can simply apply my DP. Now how to apply my DP? As simple as that. We'll have the DP initialized. We'll go on to all the characters, all the indexes one by one. The first basic check which we already had, that if I-1 is actually equal to -1, or my DP of I-1 is true, only then I should start comparing my ith character. Remember, as I previously spoke also, I can start comparing, if I am here, I can start comparing only and only when, okay, first case is, okay, if your I-1 is actually equal to -1, or you are, let's say here, then your I-1 should actually be equal to true. Then only you can start comparing. So I am at this index. I say, okay, if I-1 is actually equal to -1, or it's actually true, then I should start comparing. For comparison, I will use my trie. So I will go and get my current node back, which is the root node, and then I'll have to start moving in my trie to do the comparison. And I know I will compare only the string which I have, starting from the index I itself. So I'll move, I'll have my j, which will only go up till the string length. That is the best use case. You will see I will go in the string length, and the j also will go in the string length. So it is O of n square. That's how you actually are comparing only the string portion, right? Okay, great. Then you will compare you will get the current character, which is s of j, and then you will just check, okay, if that is inside my trie, I can move that. Okay, if I can move, I'll simply keep on moving. If I cannot move, I should simply break out from this loop, because I cannot compare the string now. And if I can, like, it is actually matching, I can simply move it on that specific character. And if yes, if the word is actually there, then simply that dp of j will actually become a true. As you saw, okay, you were moving in the trie, this t was a word, so dp of j was true, this dp of word was a true, so that specific dp of j is true. So that is the reason my dp of j will become a true. And that is how you will go on to all of your, if you are at the index I, you go on to j, and then j is here, and then j is here, and so on and so forth. You will keep on going, and you will keep on going on up till the string length only, because the comparison is only on top of the string length, which is a much lesser time complexity. And ultimately, the same way, if your dp of length minus 1 is actually equal to true, great, return the true itself. You will see the here you are getting O of n square because of the dp call which you are doing. It's O of n square, right? And the thing which you made here, right here, the building of trie, it's actually O of m into k. So you reduce the time to just, and with this it is equal to O of m into k only. That is how much your time is reduced. But the space has increased a bit because now you are building a trie. So in the worst case, you have to go on and plot every of the node of trie, which can be O of m into k. And for sure, dp space will always be there. But reduction in time is what we require the most. I hope that you guys got all the approaches from brute force to recursion to top down to bottom up to trie, which is actually a big video. Like the length has gone pretty long, but yeah, I hope you guys take care. Bye bye.